Hello students, myself Dinkar Satonkar again welcomes all of you in this part 6 of chapter motion of 9th class physics. In part 5 we have studied about what is called as the speed of the light, speed of the object. Here in this part 6 we are going to study about velocity of the object. Initially it looks same that speed and velocity are same quantities, but seeing in detail speed and velocity are altogether different quantities. So let's try to understand in this particular part what does it means by velocity. If we want to represent the velocity in a definition form, the definition of the velocity will be like this: distance traveled by a moving body in a particular direction in unit time is called as the velocity. There are few other definitions are also available for the velocity. Any of the definition you can consider. All these definitions are correct. All these definitions you can, any of the definition you can write for the examination purpose. So second definition is the rate of change of displacement of the object. Here rate of change, I would like to throw some light later on this word rate of change. Third definition of the velocity is like this: the physical quantity which specifies the rate of motion as well as its direction is called as the velocity. Previously I told you that there is a small difference between speed and velocity, although the speed is that particular word which we use in our day-to-day life, and for that reason the velocity word is a more technical word because there is a difference between speed and velocity. Let's try to understand with the help of these definitions what is the difference between speed and velocity. So if you look the definition of velocity carefully, you will find that the velocity is the distance traveled by a moving body in a particular direction. Here two words are important. First is nothing but this distance, and the second word is nothing but this particular direction. So whenever the motion of the object is considered, the object is moving, it is covering some distance, but if this distance is coupled, if this distance is considered in a particular direction, then that particular distance in a particular direction in unit time it is considered, then that is called as the velocity. So as the velocity necessarily be consisting of the direction in which the object is covering the distance, so that's why direction word is important over here. Second definition of the velocity tells us that the rate of change of displacement of the object. Now here this rate of change, this particular word tells us about the displacement is changing, but this displacement is with respect to time. So whenever you will find such kind of word rate of change, then please understand that this rate of change, that means some quantity is changing with respect to time. So this is the meaning of this rate of change. So the rate of change of displacement of the object is called as the velocity. Or the third definition is also is there for the velocity: the physical quantity which specifies the rate of motion as well as its direction is called as the velocity. Now velocity is a physical quantity, now by which we can represent that quantity. So that's why the velocity is a physical quantity. But here rate of motion, because the velocity is nothing but represented with rate of change of, so this rate of change is in terms of displacement, this rate of change is called as the rate of motion. That's why this rate of motion as well as this direction, this motion is enabled with the direction, so that's why the words are used in such a way that it represents the direction of the motion of the object. So the physical quantity which specifies the rate of motion as well as its direction is called as the velocity. Now if you look all these three definitions, you will find that repetitively this direction word is coming over here. So we can understand from these the word which is coming in all these definitions, direction along with the magnitude is necessary for the representation of the velocity. Here is the basic difference between the speed and velocity, because the speed is represented with magnitude only, there is no any necessity of the direction to be represented along with the speed. magnitude is sufficient enough, with the help of which magnitude can be completely speed can be completely represented. But velocity, along with the magnitude, the direction is necessary. That's why the velocity is a vector quantity and speed is a scalar quantity. So when the distance traveled per unit time, but it is represented with the particular direction, that is called as the velocity. Now there are some important points by which we can understand the velocity concept thoroughly. Let's try to understand what are those important points over here. The speed of the body gives the idea about how fast the object is moving or how slow the object is moving. We have seen in the while we have seen the detailed information about the speed, we have seen that many objects are traveling with the different speeds. Some objects will take less time to cover a particular distance, some objects will take more time to cover a particular distance. So how the object is moving, whether the object is moving in a fast manner or the object is moving with in a slow manner, that is represented with the speed of the object. Speed of the object does not tell any information in which direction the object is moving. So speed does not give information about the direction, but the velocity gives us the information about magnitude as well as direction, because we have seen in the definition of the velocity that the direction is necessary to represent it completely. That's why along with the magnitude, the direction is also being represented with in the concept of the velocity. So that's why velocity is a vector quantity. This is the basic difference between the speed and velocity, that is speed is a scalar quantity, however velocity is a vector quantity. Now what is the SI unit for the velocity? The SI unit for the velocity is same as that of the speed. In MK system it is represented by meter per second, in CGS system it is represented by centimeter per second. This can also be written as meter s to the power minus 1, because this is divided by s, so it can also be represented as s to the power minus 1. Or this CGS unit system can also be represented as centimeter per second, that is cm s to the power minus 1. So this is the unit of the velocity. The unit for velocity as well as the distance speed is same. Now if you see the formula about the velocity, we have to write the formula for the velocity. Velocity is equals to change in displacement divided by the time interval. Now in this time interval, this much change in the displacement happens to be there, so that's why we used to write here for the formula of the velocity, velocity is equals to change in displacement divided by time interval. Now in a notation form, in a formula wise, we can represent it, it's v is equals to delta x divided by delta t. Here this arrow is important to represent, because whenever any quantity which is in the vector form we have to represent, then that quantity must be associated with an arrow on the head of that particular notation of the quantity. So same notation is used for speed also, but there is no arrow on the head of the v when we talk it about in terms of speed. But when we talk it about the notation for the velocity is also represented by v, but there is requirement of the arrow over the head. This arrowhead represents that it is a vector quantity. So v is equals to delta x divided by delta t. Delta x, here delta represents that a small change, this small change may be in the form of displacement, and this small change in the form of the time also. That's why delta x is the small change in the displacement and delta t is nothing but the small change in the time, which is nothing but the time interval. So v is equals to delta x divided by delta t. Now many times it is possible that an object may not be performing its motion with a constant velocity. Sometimes the velocity of the object increases, sometimes the velocity of the object decreases. So we have to consider the average velocity of the motion of that particular object. So when we talk it about the average is nothing but say average of two terms or average of three terms, then we have to take the arithmetic mean. So average velocity can also be defined as, if the velocity of the body is changing at a uniform rate, then average velocity is arithmetic mean of initial velocity and final velocity for a given time period. So let's consider that an object is moving initially with some different velocity. Finally, when the object reaches at the destination, it may have some different velocity. So depending upon the initial and final velocity, we have to write the formula average velocity is equals to initial velocity plus final velocity divided by 2. In formula wise it can be represented as V average. Average avg represents, this suffix represents that it is an average. So u plus v divided by 2, where u is nothing but the initial velocity of the object, v is nothing but the final velocity of the object, and u plus v divided by 2 represents the average velocity. So this is the introduction information and introduction about the velocity of the object. In the next part we'll see about the difference between velocity and speed, and on the depending upon the speed and velocity we'll see about what is called as an acceleration of the object. So up till, just take a look on this speed as well as velocity. Thanks.